Hello everyone. So in this lecture, we will talk about normalization. Normalization comes under database management system. It is actually the base of database management system. So in this PPT, we will learn about its introduction. What are the good quality database design goals? What is data redundancy and its associated issues? After that, we will learn about relational schema design issues. Now, based on this, why we need normalization and what are its normal forms. Okay. So we already know that ER model helps the database designer in order to identify its entity types, their attributes, associated attributes, and relationships between these entity types. Okay. Now, in a single relation schema, it consists of several attributes, means all its properties. For example, if we have created a database of student, a table of student, a relation of student, all these terms correlate, means relation, table, relation schema, correct? So then it will be having columns as roll number, name, father's name, mother's name, address, phone number, etc. So what are all these? All these are attributes of relational schema student. So a relational database schema consists of several relational schemas. What I am trying to say, single unit is attribute. More than one attributes, more than one relative attributes will make a relation schema, and associated or relatable relational schemas will make a relational database schema. Correct. Now, what we need to know? We need to know that some formal way of analyzing why one grouping of attributes into a relational schema may be better than another. Measure of appropriateness or goodness to measure the quality of design other than designer institution. What is this? Means suppose we have a land, that on that land more than one architect will have different designs to make a house. Okay, now how I will check which design is better? Correct. Similarly, we can have more than one designs of a database. We can have more than one grouping of attributes into a relational schema. Now, what I am trying to say, how we will select which approach is better, which design is better. For that, we need normalization. So what are good quality database design goals? Main goal is information preservation. Why? Because it maintains all concepts, including entity types, attributes types, relationship types, and generalization specialization relationships, which is described using the ER model. Then its another design goal is to reduce the redundancy. Okay, what is redundancy? If information is repeating, okay, if same kind of information is stored multiple times, then it is redundancy and we have to minimize it. Why we need to minimize it? Because data redundancy associate with various issues. We have three type of issues, that is insertion, updation, and deletion anomaly. What is insertion, updation, and deletion anomaly? Let us take with an example. Let us see with an example. Suppose we have a database, faculty details, under which we have attributes: faculty ID, faculty name, middle name, last name, designation, date of joining, gender, salary, department name, and department location. If we see this database, then we can check that same type of information, that is CSE Aryabhatta block, CSE Aryabhatta block, CSE Aryabhatta block is repeating 3 times. Okay, it is a small database, but if we have a database of 1,000 faculties, then this information will be repeating how many times? 1,000 times. It will waste our memory also, and this relationship will suffer with insertion, deletion, and updation anomaly also. Now, what is insertion, deletion, and updation anomaly? Let us check one by one. Insertion anomaly. Now, what is insertion anomaly? Suppose college starts a new department, CSDS, at Baba Block. And in this department, we don't have any faculty right now. Now, according to this database schema, can we insert this information into this table? Let us check. For this table, we have primary key on faculty ID. Okay. Now, in this faculty ID, in this table, we since primary key is faculty ID, so we need to insert faculty ID for sure. But CSDS department don't have any faculty, so we don't be able to insert CSCDS data department information in this table. It is the first anomaly. Reason for this anomaly is data redundancy. If we remove this data redundancy, then we will be able to remove this insertion anomaly. We cannot store the data of this new department in the above relation, and the faculty ID being a primary key cannot be null for a tuple or a record. We call a tuple as a record also. Now, what is updation anomaly? Suppose the location of department is changed. Now, the suppose CSE department location has been changed from Aryabhatta block to Baba block. Now, the new location needs to be updated for this particular department in all the rows, in all the tuples where it appears. So while carrying this updation process, if we miss any row tuple within where this department appears, then this department data will be in inconsistent state. Okay. This is a small database. Here we need to update this information only for 3 times, Aryabhatta to Baba. But if we have a record of 1,000 of people, where in CSE we have 1,000 faculties, then we need to update this information 1,000 times, correct? And if we miss even in a single record, then the database will be in inconsistent state. How we will identify whether CSE is at Aryabhatta or Baba? Another anomaly is deletion anomaly. Suppose faculty ID 2765, name is Girish, this one, 4th tuple. Suppose this faculty ID leaves the college and his record is deleted from the database. Now we can see that he is the only faculty in mechanical department. Now if we delete this anomaly, then the department mechanical will also not exist. Correct. क्या गिरीश के छोड़ने से मैकेनिकल डिपार्टमेंट बंद हो जाएगा? No. So this will leads to deletion anomaly. If we remove faculty, last faculty of any department, then department won't be lost. So all these are the anomalies associated with data redundancy. And if we remove data redundancy, then we will also get rid of these anomalies also. Next is now suppose now if we decompose the above relation schema into 2 separate relations. Suppose this was our table. If we decompose this into these 2 tables, one is faculty and one is department. Under faculty, we have faculty ID, faculty name, middle name, last name, designation, date of joining, gender, salary, and department name, where this department name is having foreign key that comes from another table, department name. Here department name is primary key, and we also store its location. Okay. Now suppose if we see our anomalies, insertion anomaly. Suppose if we insert any new department, CSES, are we able to insert? Yes, we will able to insert CSE department, which is at Baba block, but here no faculty is associated in CSE department, but CSDS department exists. Fine. Another anomaly was updation anomaly. Suppose you are trying to update CSE department location from Aryabhatta to Baba. Here we have to update this information only at one time. CSE department will be at from Aryabhatta to Baba. All will update simultaneously. We need not to update many times. Only one time we need to update. Another anomaly was deletion anomaly. Suppose Girish left the college. Girish left the college. Okay, just remove this tuple and Girish still mechanical department exists in department table. Fine. So relational schema design issues will be resolved if we decompose such a redundancy into more than one tables. Fine. This is known as decomposition. So the process of eliminating the relation design issues and related anomalies is known as normalization. Means if we eliminate all the design issues and their related anomalies, and if we reduce the data redundancy, then it is actually the process of normalization. And for this normalization, as discussed, the process of eliminating the relational design issues, mainly data redundancy and related anomalies, is called normalization. And when we convert the ER model into relational model, in most cases, substantial normalization is already achieved by virtue of implicit and explicit constraints discussed in earlier units. However, we will discuss all the normal forms in detail to understand the normalization process. And we have 6 normal forms. First is first normal form, where all the attributes should be atomic, means multi-valued and composite attributes are not allowed. This we will discuss in detail later. In second normal form, partial dependency should not be there, means any dependency should be fully dependent on candidate key. Part of candidate key should not find any attribute. We will discuss in detail later. In third normal form, we don't have any transitive dependency, means it actually based on transitive dependency, means we should not have non-prime to non-prime dependency. We will see this later. In BCNF, that is boycott normal form, all the LHS should be a super key, means whatever we are finding that should come from came from any super key. Then we have fourth normal form and fifth normal form. All these normal forms we will discuss in detail later in our next slides. Thank you.